idea of a limit is this. Here's a basic, very simple example. I have this function, f of x is x plus 2, and I want to know what happens to this function if I plug in values that are very, very close to 0. How close to 0? Well, we may be able to get to that, but really, today we're just going to look at an intuitive idea, just very close. And this one is not hard to think about. If I choose values of x that are very close to 0 and plug them into this function, the output is going to be, well, it seems obvious to me. It should seem obvious to you, I hope. If x is close to 0, then the function value is going to be close to 2. Right? So the idea of a limit has to do with what is happening to y as x approaches, we say, some value. What is happening to y as x approaches some value? And it looks like here, my y value, my function value, is getting close to 2 if x is getting close to 0. That was the question. What happens if x is getting close to 0? We write it like this. The limit as x approaches 0, the limit tells me I'm wondering about x getting close to something, and I want to know what y is getting close to. And then beneath it, I write x approaches 0. So I now know that x is getting close to 0, and here is my function. Right? This is my y value. What is happening to this y value as x is getting close to 0? And the answer is, it's getting close to 2. And we write the limit as x approaches 0 of x plus 2 is 2. That one was kind of easy. Let's look at another one. Consider this function. F of x is x cubed minus 8 over x minus 2. And I want to know what happens to the y values, the values of the function, if I am letting x get really close to 2. It's not as straightforward as the first one. If x is getting close to 2, the top appears to be getting close to 2 cubed would be getting close to 8, and so 8 minus 8 would be getting close to 0. The numerator would get close to 0. And the denominator, well, if x is getting really close to 2, and I subtract 2, I'm going to be getting really close to 0. And you should have learned somewhere in your past life, somewhere in middle school or before maybe, that you can't divide by 0. This is not allowed. Nevertheless, that doesn't help me answer. Does this mean it's not getting close to anything? Well, we are just trying to get an intuitive idea. So what we're going to do is we're actually going to plug in some values. This is an intuitive way. This is not rigorous. I'm not being rigorous right now. I'm just trying to get an idea. So I'm going to use Desmos. So you could go to desmos.com or you could use a graphing calculator. Desmos does this especially well. And I want to graph. When you go to desmos.com, you say start graphing. It's going to take you to this screen, and I'm going to define a function. I'm going to say that f of x, well, of x is, and I need parentheses, what was it? It was x cubed minus 8 divided by x minus 2. And let's get rid of the keyboard. Look at this. I'm going to look at the function right now, the graph, for a second. It looks to me, if x is getting close to 2, It certainly doesn't look like a no value that we thought it might be. It looks to me, if x is getting close to 2, that the y value is getting close to 12. It certainly looks like that to me. Just by paying attention to this graph. But I could use this. I could plug in some values. Let's see. What is really close to 2? I could find f of 1.9. F of 1.9 is 11.41. Put in another 9. F of 1.99, 11.94. Put in another 9, 11.99. These numbers seem to be getting close to 12. Let's go to the other side of 2. F of 2.01. That's 201. I missed the decimal place. 2.01. 12.06. Let's put in another 0. Oh, it certainly looks like if x is getting close to 2, it certainly looks like, at least in sort of a guess, that y is getting close to 12. I'm going to write there. And remember, this is a guess. Now, guessing like that can have some problems. I'm going to show you this one. This is a very strange function. F of x is 1 million x to the fourth minus 4 million x cubed plus 5,989,900 x squared minus, you can read that all. And I want to know this. What is the limit as x goes to 1 of f of x? And so I'm going to plug in some numbers. I'm going to plug in to that function 0.9, 0.99, 1.1, and 1.01 to see, perhaps I could guess what that function is getting close to. Now, in fact, I'm going to put the link on Canvas for the Desmos file that already has this function input. And I want you to go to Desmos using that link, plug in 0.9, 0.99, 1.1, and 1.01 into the function the way I did here, f of 2.001. So you're going to have a function here when you hit the link. Plug in those 4 values and then see if you can guess the value as the limit goes, as x goes to 1 of that function, and then come back to the videos.